Okay, let's resume. So these are the reasons that a process can be suspended. It might be swapping. Swapping means the operating system is out of memory, and to actually release sufficient memory to bring in a new process, okay, that we actually swap some process from the memory. So this is called swapping. Then we have some other operating system reasons, like we can actually suspend a background or utility process that is suspected of causing a problem. So the problem can be a privacy problem, it can be a bound violation, and so on. Then we have interactive user requests. The user wish to suspend the execution of a program for purpose of debugging or in connection with the use of resources. And then there's a timing issue. A process may be executed periodically. Let's assume an update function. Okay, so what happens? The update function checks for update in after 24 hours every day. So this is the timing issue. So for the rest 23 hours, it actually remains suspended. Then just for 1 hour, it checks for updates, and then it goes back to the suspension again. And then we have the parent process request. So a parent process may wish to suspend the execution of a descendant to examine or to modify the suspected process. So these are the various reasons a process can be go to suspension. Now, as you can see, the operating systems actually have a lot of tasks at hand. Okay, the operating system is not only actually have to manage all the resources, it has to allocate the resources as well. So to control everything within the computer system, operating system actually needs to somehow keep track of everything. And to keep track of everything, or to ensure to manage everything, all the resources, okay, it needs some way to store all this information. So basically the process description is actually not given by the process operating system. So the operating system actually needs to store all the information related to the process. Now, whenever operating system is handling different type of processes, okay, it does, it uses a structure that we call process system for control structure. So a control structure that controls everything using a process system. So first, OS must have information about the current status of the process and the resources, and OS constructs and maintains tables of information about each entity that is managing. So basically, the operating system must have information about the current status and the resources, but we know that it actually difficult to manage, and it actually most cases is not done. And also in OS, okay, the constructs and maintains table of information are different for different entity. Okay, for some resources, like if you're a user program, okay, some of the privileged instruction might seem actually uh, off the book for you. Okay, those might not be allowed for you. Okay, so say overall, basically the basic idea is to manage all these huge resources that our computer have, okay, to make sure that we have actually finished everything correctly. The operating system maintains this control table. The table has 4 parts: memory table, IO table, file table, and the process table. Each of this table, as you can see, memory, device, file, and process, each of this table contains different information. Memory table contains information about all the memories, IO device table for all IO devices, file table for all the files stored in the computer, processes for all the processes stored in the computer and their image. So now we will see, okay, what type of information is stored in these 4 type of tables, and we will see what is a process image. Then we are done with today's class. So as you can understand from the definition, memory table, what it does, it keep tracks of both the main, the real memory, and the individual or the secondary, the virtual memory. So it keep tracks of all the memory. Okay, some of the main memory is reserved for use by the operating system. The remainder is available for use by the process. So some of the main memory, we always keep it reserved for operating system. Why? Because you see, operating system itself is a program. Okay, we have studied that operating system has more than 4 parts. In the in the main part, that we have the kernel that runs all the time. So you see, or then we have the graphical user interface. So all these are also program as well, and they actually needs to switch between one program to another program. They needs to store the programs and so on. Then the process are maintained on secondary memory using some sort of virtual memory. So it has actually been not easy for you as well. The memory table must include the following information: allocation of main memory to the process. So we have to allocate the main memory, the allocation of secondary memory to a process. And then we have any information need to be managed without virtual memory. So these are some of the information that we must include. Then we have this IO table. As you can understand, we manage all the IO devices, input output devices, and channels the computer system. So if you have a mouse keyboard, it might happen that you have already got mouse, but you're waiting long time for the keyboard. So the status of the IO operation is read by this IO tables. And finally, we have the file table where all the file is stored. Okay, so we have actually survived that we don't have to write programs. But in short, in this file table, we use existing all the files, the location of the secondary memory. The application is from main memory as well. Then we have this information that maintained and used by the file system. So file system, even though it's very careful, it has its own way to represent things. In other words, that operating system much detail of the file management, where each file is stored, how they are stored, do this need any type of information, and so on. So these are the three. IO table handles IO related, then the process table for process related, and then we have this memory table for memory related. Now we will see what is a process table and what is a process image. Then, as I said, we are done. So operating system must maintain a process table to manage processes. Okay, nice. Before proceeding to the discussion of the extra required process table, two additional points we need to make. First, there must be some reference to the resources such as memory, directly or indirectly in a process table. So whenever a process starts, okay, we have seen that somehow you need a guideline. Okay, it needs some the references that where and which resources some software is using. So for me especially, it happened that I was using always the same one, and we had this picture as well. And secondly, the resources are actually there. And then how does the operating system know to create the table in the first place? So how actually they can predict what will be the informations will be there. So these are the two conditional points that need to make. First of all, the reference of the resources, and then which program to actually create, how to actually keep track. So first of all, let's answer the first question. So where the process is located. Secondly, that are which are important. So to understand this, that which process are important, we'll start with the process image. A process image typically contains user data, user program, system stack, and process control block, PCB. And what is a PCB? We have actually learned PCB in the second lectures. If you're not clear, go through one of the lectures before that. So we have user data, user program, system stack, and process control block. So these are all the typical elements of process image. And what is the process location? So we have to somehow know where the process is located, so that every time we actually execute an instruction, we can just go there and execute the instructions. So this is all about the process location. So